when you look at these first four, this is just an example showing you when you look at the variable, if it's a positive number, you're not going to change your inequality symbol. That's going to stay the same. When you scoot over to the next one, it has a positive 4x or add 4x, so your symbol is going to stay the same. No need to flip or reverse it. This has positive 2x. I would be dividing by 2 at the end, so that's going to stay the same. And this has positive 9x. So again, my symbol is going to stay the same. But this was just real quick to identify that the variable number was positive, and therefore I'm just going to solve it like normal and keep my symbol the same way. On this slide though, however, you can see that we're going to have some variables that have negative numbers in them. That means at the end I would divide by -3 on this. If that happens, now my symbol is going to have to flip or reverse and go the opposite direction. If you skip over to the next one, it has -5y. Because it's a negative, I'm going to divide by -5, and therefore my symbol also needs to flip or reverse and go the opposite direction from the way it was at the beginning. The bottom two, you look right in the center. This says subtract or -2x. Okay, that means I'm going to need to flip or reverse the symbol because I would be dividing by -2. And this last one, it says subtract x. That if there's no number there, it means 1. It still is going to be dividing by -1. Therefore, I'm going to have to flip this symbol, reverse it, and go the opposite direction. Just a quick look at something you need to identify when you're getting ready to solve. Alrighty, now we're going to do one for real. When you look at the question, it says 6 times something, 6m, take away 7 is less than 41. When I solve equations, I like to separate them. I draw a line down the inequality symbol or the equal sign, whichever type I have, and then I start working backwards. Step 1 earlier said add or subtract so that you can isolate your variable. For this one, it said I was originally going to subtract 7. Therefore, the opposite of that is add 7. Wow, that was really messy. Let's try that again. Add 7. Add 7. Oops. These two numbers right here are going to cancel each other out. That's how I'm isolating to just keep 6m. Once I do that, I am going to keep 6m right here. And it said less than. And over on the far right, it said 41 and then add 7. So that's just going to stay a positive, and it's going to be 48. Now that I'm down to this final step, it says 6m. Well, some people are going to say, I just know this and it's 8, which is fine. It's going to be dividing by a positive 6. If I divide by positive 6, there's no need to flip or reverse this sign. And then I would just say m is less than 8. If you haven't graphed inequalities before, you take the number that you got for your answer. This is the number on the number line that's going to get a circle, or it starts from. And then the way this arrow is pointing, because I'm reading it from left to right, any answer is less than 8. So I would put a dot on 8. Let me make this a little bit bigger. I'm going to put a dot or a circle that's open on 8. 8's not equal to, so the circle can't be filled in. But then the inequality says every answer less than 8 would fulfill this and make it true. I'm just going to draw a line going this way and then put an arrow saying all answers continuing less than 8 make it true. The next example says negative 3 times something plus 9 more is greater than negative 21. Again, on this one, I'm going to start my way with drawing a line down the inequality so I can separate the left side and the right side. I noticed that this one starts out by saying add. So the opposite of add, if I need to isolate the variable, the opposite of add or positive 9 is subtract or negative 9. Okay, that let me get rid of these 9s so that I can isolate and just keep negative 3t all by itself. I'm going to go ahead and put that down here. Negative 3t is greater than, and if I look over on the side, this one had negative 21 minus 9. If I'm already in the negatives and I'm going to take away 9 more, that's going to increase the amount of negatives I have. So actually I'm going to add these together. 21 and 9, that makes 30. And altogether it's negative 30. I'm at my final step. The final step, the opposite of multiplying by negative 3, is dividing by negative 3. On this one, it's really important. I need to flip the sign or reverse my sign, and it's because I had to divide by negative. I'm dividing by negative 3. That's really important, especially when you have an assessment and there are multiple choice answers. Usually both choices will be there, but with the sign going a different direction. So watch out for that. When I finish, my answer should say t, but instead of keeping it greater than, I need to flip the sign. So it's going to switch, and now it's going to become less than. And that t looked like a plus sign, so let me make it bigger. T is less than negative 30 divided by negative 3. If you have two negatives and you divide them, they become positive. So this would be a 10. And another thing that we use in my class, I don't know if anyone else does, is we use this little face, and we call it math dude, and we put in 2 negative signs for some eyes and a plus sign for the mouth. And for my kids, this kind of helps them know if the answer is going to be positive or negative. In the question, I had negative 30, so that takes out this. And then I had negative 3, so that takes out this. And that means the only thing left over, my answer has to be positive. If you have trouble using the positive-negative rules, you could do that. All right, so now I'm going to graph. My answer needs to be starting at 10. I'm going to put a circle on 10 on the number line. This only says less than. It doesn't say equal to, so I'm going to leave my circle open. Make my number line a little bit bigger. Well, maybe not. Okay, I'll leave it there. I'm going to put my circle on 10. And it says all answers less than 10. I'm going to draw an arrow going to the left. That means anything less than positive 10 would make this inequality true. All right, here's a couple more examples if you needed some more to look at to help you understand what's happening and when you do and do not flip this sign. You could pause the video and take a look at these and see what's happening. Hopefully this helped you solve inequalities, and those two number lines help you see how to graph your answer.